So hi all, my name is Gulshan working as an assistant professor AI and DS department. So in the continuation of the previous video, in the today's session we are going to see like what is Bayesian network and how it is being involved with it. Okay. So now in this Bayesian network we will see like what is joint probability distribution. Okay. Now in this joint probability distribution, it is nothing but the fully joint distribution probability distribution specifies the probability of the values to random variables. Okay, it uses it is usually too large to create or use in its explicit form. Okay, joint probability distributions, for example, in these two variables is given as probability which is having a true value and a negative value. Now the probability distribution for n variables requires 2n entries with all possible combinations. So what is the drawback of the joint probability distributions? The first thing is large number of variables and grows rapidly. Time and space complexity are really very huge. Statistical estimation with probability is difficult. Human tends signals out of few proportions. The alternative of this is the Bayesian network. Now, what is this Bayesian network? Bayesian network is to represent the dependencies among variables and to give a brief specification of all fully joint probability distribution. Okay. A Bayesian network is a directed graph in which each nodes are variables and edges are relations. The full specification is as follows. A set of a random variable makes up the nodes of the network. Variables may be discrete or continuous. A set of directed links or arrows connects each pair of the nodes. Okay. From X it is being connected with Y. So it can be connected with Y from X. It depends. Okay. Each node X has a conditional probability distribution of P of X of something that quantifies the effect of parents of the nodes. The graph has no directed cycles. Example is given. So A and B are unconditional and it is also independent and it is evident it is a parent node, and C and D are conditional, dependent, and they are the children node. So as a previous video we have seen like how the probability is being distributed. For each thing you will be given some value and you have to calculate it based on the formula, that is nothing but the Bayesian rule. Now the next example is the cavity problem which we saw in the previous video. Okay, you will be having different values of say for example cavity, toothache, catch, and weather. Weather is an independent variable. So the next example is also burglary alarm, which we already have seen in the previous video. So in this you will have a new burglary alarm installed at home. It also responds on occasion to minor earthquake. You have two neighbors, that is John and Mary. They promise to call you when they hear the alarm. John always calls when he hears the alarm, but Mary likes rather loud music and sometimes he misses the alarm. Given the evidence of who has or has not called, we would like to estimate the probability of burglary, which we are already seen. Okay, we will be calculating based on that. We can calculate the probability that the alarm has sounded, but neither a burglary nor an earthquake has occurred in both John. For that, they are calculating probability of J and M and A and negation of B and negation of E. Okay, when you are calculating with the product rule that is being already seen in the video, you will be getting a basic value. Okay, the next thing that we are actually going to see is the kind of the semantics of Bayesian networks and how it is being involved. So I guess in this video you might have learned like what is Bayesian network and how it is being involved and what is the different kinds of process that is being involved in it. The next video we will be seeing like what is semantics of Bayesian networks and what are all the different process that is being involved and how how the entire process is being involved. Okay, so yes, I hopefully make sure that you people understand the concepts of Bayesian networks. In the next video, we will see with the semantics of Bayesian networks. As of now, thank you. Have a good day.